I want to use this simulation to show the critical angle. So if you're asked to find the critical angle, what they are talking about is at what angle does the incident angle have to be for you to get like a 90-degree angle in the refraction angle. So I'm gonna use this laser here to show you. Here, as you can see, I don't see a refraction angle. It's just reflection, and both angles are the same. But if I move the laser, if I move the light, there it appeared. You see it? So the closer I get to the normal, also the closer the other one gets to the normal. So you're always gonna get, if it's a 0-degree angle from the normal, you're always gonna get 0, but as it goes is when it diffracts. However, as you keep going and it gets closer and closer to this x-axis or the other medium, if you reach 90 degrees, well, at 91 is not going to be at the same medium anymore. It's going to be at the other medium. So that is your critical angle. So you cannot go beyond this, or you simply are not going to get any refraction in the other material or the other medium. So the question again is, what is this angle, this critical angle, so that I get the 90 degrees? So this is my angle of incidence. So my angle 1, I guess, is the one that I need to find. And my angle of refraction is going to be 90 because I am trying to find my critical angle. So I have like an example here with water. So you have the ray coming in, and if you get 90 degrees on the other side through the air, I guess that is your critical angle. So we're trying to do this example here. So I have two random mediums. One has a 1.6 refraction index. The other one has a 1.29. There you go, refraction index. So pretty much what is happening is the ray is coming in at my angle 1, or my angle of incidence, and here what I'm getting is an exact 90-degree angle. So that's the maximum that I can go for my angle 2. So I am going to use the formula for Snell's law, and 1 sine of the angle 1 equals n2 sine of the angle 2. So I'm just gonna substitute. So m1 is 1.6, sine of angle 1 is the one that I'm trying, 1.129 times the sine of angle 2, which is 90 degrees. Okay, so I am gonna be solving for the unknown, so I'm gonna divide both sides over 1.6, so it cancels out on the left side, and I end up with sine of angle 1 equals, and pretty much is gonna equal what I have already there, the 1.120 of 90 over the 1.6. So on the calculator, now I'm gonna move over here. I am gonna put that, so I have 1.129 times the sine. So I'm gonna use the function and make sure that is in degrees, not in radians, so you're not gonna get the right answer. Sine of 90. And here you see is just the top part of the multiplication is 1.129. If you switch to radians, you get a totally different answer. So be very careful or you're not going to get the right answer. Has to be in degrees. Okay, now that divided by 1.6. So it's 0.705. Do not round. Leave the long number. Now here's the thing. This is not the answer. That is not angle 1. That is the sine of angle 1. So how do I find the actual angle? Okay, so here's what happens. You need to use the inverse of the sine, because sine of an angle is not a multiplication. Sine of an angle is a number, and it is 0.705. So for you to actually have or solve what the angle is, so angle 1 equals, I should have erased this, the inverse of the sine, which is sine to the -1 of all of that. That is what I'm looking for. So my angle 1 is, and now I'm gonna simply take the whole thing and I'm gonna click sine to the -1, and there you go, sine to the -1 of all of that is the inverse of the sine and gives me the actual angle, which is 44.88. Why did I did it like this? Because if I round, you're not going to get the exact angle. You're going to get 49, 50, or lower, 40, 43, and that's not the angle. So make your biggest effort to keep in the memory of the calculator as many digits as possible to get the most or closest answer to be very accurate.